Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 24. Let's get started. Alright, our job today is to describe all of the values for r, or our variable, in this case r, that will make this statement true, and all of the values for r that will make the statement false. So we worked on this in class yesterday. We're going to get a little more practice with this today, and then we'll move on to solving these problems with algebra. But first, we have to understand how to figure out when the variable, what value the variable has to be to make this true, and what value the variable has to be to make this statement false. We talked in class about finding the balance point. So the balance point is when both sides are equal. So what I'm really trying to do is figure out, what does r have to be so that both sides will be 25? And in this case, I know that if I add 10 to this side, 10 plus 15 will equal 25. And then the two sides will be equal. So when I write my true and false statements, I'm going to say this statement is true when r is equal to 10, and this statement is false when r is everything else. So in this case, when r is 10, the statement's true because 10 plus 15 is 25, and 25 does equal 25. So this is a true statement. So when r is 10, the statement is true. When r is anything else, it's going to be false. If r is less than 10, it's false. If r is greater than 10, it's false. So I have to say that. And I'm going to say that by using a compound inequality. I'm going to say r is... It's false. This statement is false when r is greater than 10, and it's also false when r is less than 10. And remember, we talked in class about reading from the variable. So if I start with the variable r and I read in this direction, it says r is, well, I get to the big part of the sign first, so it means greater than. R is greater than 10. And if I read in the other direction, in this direction, now I get to the small part of the sign first, which means less than, so this says r is less than 10. So it's false, right? This part right here, it's false when r is greater than 10 and r is less than 10. And that's everything, right? That's all possibilities to infinity. We have 10, we have everything bigger than 10, we have everything smaller than 10. So there's part A. A lot easier when they're equations because there's only one way that it's true. But in an inequality like this one, there are an infinite number of ways that make the inequality true, and there's an infinite number of ways that make the inequality false, and we have to find that balance point. So again, trying to figure out the balance point, I need to know, what does d need to be so that both sides are equal? Well, I've got a 0 on the right side of the inequality, so I need to make this side equal to 0, and that would mean d would have to be 6. So when I write my inequality statements, I'm going to say that it's true. This statement is true when d is something. I'm not sure exactly what my signs are going to be yet, but I'm going to skip that part. But I do know that my balance point is 6. So it's true when d is something to 6, and it's false when d is something else to 6. So these spots I got to figure out. I need to know what my signs are. So that's what I'm going to work on. I'm going to try to figure out what the signs would be. So my first thought is, well, what if D is 6? So let's start there. What if D is 6? Well, if D is 6, I can rewrite this inequality and it would say 6 is less than D is 6, so that's a 6. And that's going to be greater than 0. So 6 minus 6 is 0. So my statement now reads 0 is greater than 0. That's not true. In fact, that's a false statement. 0 is not bigger than 0. So that's a false statement. So my equal sign, right? Remember, I said that D was going to be a 6. So when D is 6, when it's equal, when D is 6, it's a false statement. So I'm going to put my equal sign, part of my inequality, on the false statement, which is going to tell me when the statement is false. Because when I put a 6 in, up here, it gave me 0 is greater than 0, and that's a false statement, so the equal sign goes to the false. Now I just need to figure out what's the rest of my inequality symbol. Is it going to be a less than sign? Is it going to be a greater than sign? Am I going to point left? Am I going to point right? Well, I just have to choose something bigger than 6 or something smaller than 6. It's really up to you. I'm going to choose smaller than 6. So I'll choose 0. 0 is smaller than 6. It's easy to calculate with. So 6 minus 0 is greater than 0. Well, 6 minus 0 is 6. 6 is greater than 0, and that's my inequality statement, and that's true. So remember, I chose a number smaller than 6, something less than 6, and it gave me a true statement. This was a true statement. 6 is greater than 0. So on my true statement inequality, I'm going to say that anything smaller than 6 makes it true. And if that's true, anything smaller than 6 makes it true, then anything bigger than or equal to, greater than or equal to 6 will make it false. And we can check these, right? I could say, well, let's see if that's true. Anything greater than or equal to 6 is false. Well, let's choose something greater than or equal to 6. 10 is greater than 6. So let's go 6 minus 10 is greater than 0. And then 6 minus 10 is negative 4. Negative 4 is greater than 0. That's false. Well, that's what it told me it should be. Anything greater than or equal to 6 is going to create a false statement. Anything less than 6 will be true. All right, part C. Remember, we're trying to find the balance point. So every one of these starts the same way. The statement is true when the variable is something, and the statement is false when the variable is everything else. So what I'm looking for first is the balance point. So let's look at our equation this time. It's an equation. Well, we know for sure it's an equation, so there's only one way that it's true. There's only one number that will make this true. Half of that number is 15. So half of what number is 15? Well, half of 30 is 15. So f would have to be equal to 30. And if f is equal to 30 makes it true, then if f is anything else, it's going to be false. So I'm going to move my f over a little bit so I've got room. And I'm going to say, I'm going to use a compound inequality. I'm going to say if f is greater than 30, it's false. And I'm going to say if f is less than 30, it's false. Remember, we're reading from the variable. So we're choosing to start our interpretation of these inequality symbols by reading from the variable. It tells us exactly what f is. F is greater than 30, and f is less than 30. So if f is greater than 30 or f is less than 30, it's a false statement. And, again, we can try it. We can say, All right, let's see, less than 30. 20 is less than 30, so half of 20 is equal to 15. Well, half of 20 is 10. Is 10 equal to 15? No, false statement, just like we said it would be, right? We said it was going to be false. Anything bigger than 30, well, let's do another easy one. Half of 40, 40 is bigger than 30. Half of 40 would have to be equal to 15, and half of 40 is 20. And does 20 equal 15? No, 20 is not equal to 15, just like we said it would be. Anything greater than 30 for F makes it false. Anything less than 30 for F makes it false. The only way that it's true is if F equals 30. All right, that's another equation. D. Some number divided by 3 is less than 10. I want to make both sides the same, so I can find my balance point. And let's see, I'm going to get myself started down here. I'm going to say it's true when y is something, and it's false when y is everything else. So let's see, both sides need to be equal to 10. So something divided by 3 that equals 10 has to be 30, right? 30 divided by 3 is 10. So my tipping point is 30. I know that for sure because my balance point is always, my balance point is always whatever the variable needs to be so that both sides are equal. And this time it needs to be a 30 so that we get 10 on both sides. And now I need to check it when y is equal to 30. So we're checking the equal sign. We're trying to figure out, is my equal sign going to go here or is my equal sign going to go there? So we just got to check it out by saying, well, what if y is 30? So we're going to substitute. We're going to put a 30 in for y. We're going to get 30 divided by 3 is less than 10. 30 divided by 3 is 10. So our inequality statement is 10 is less than 10, true or false? That's false. 10 is not less than 10. So the equal sign goes on the false side. That means I got to get rid of this one. The equal sign goes on the false side because if y is equal to 30, we get a false statement. All right? Let's see. Let me get another color here. Now we just have to check bigger or smaller. So, I don't know. I like to check numbers that will divide easily by 3 because I don't want to get decimals if I can avoid it. So I'm going to go, I'll go bigger and I'll say, what if y is 33? So I'm checking greater than. So either I'm going to have a greater than symbol here or I'm going to have a greater than symbol there. It depends on what happens when I make y bigger than 30, and I'm gonna make it 33. So y is 33 divided by 3 is less than 10. 33 divided by 3 is 11. And our inequality statement now says 11 is less than 10. That's a false statement. So anytime I get, if I use a number bigger than 30, then it's going to be false. So that I'm going to leave that greater than symbol right there. Y greater than or equal to 30 will always make it false. And I'm going to have to change this one. And I'm going to make that a less than symbol. So y is less than 30 will make it true. Anything smaller than 30 will make it true. Let me just try one just to be safe. Let me put a 21 in for y because 21 is less than 30. So 21 divided by 3 is less than 10. 21 divided by 3 is 7. 7 is less than 10 is a true statement, so it's exactly what I thought. It's true when y is less than 30. All right, let's try another one. 7g is greater than or equal to 42. I need my tipping point. So let's see, this one's going to be true when g is something, and it's going to be false when g is everything else. And let's see, I need my tipping point. So 7 times 6 is 42. That would make both sides 42. So 6 is my tipping point or my balance point. And then I just have to check where the equal sign goes. So I'm going to start that. I'm either going to have an equal sign here or I'm going to have an equal sign here. So if I make G equal to 6, I get 7 times 6 is greater than or equal to 42. And 7 times 6 is 42. So 42 is greater than or equal to 42. And this time that's a true statement. 42 is equal to 42. So this is true. That means that the equal sign portion of my inequality is going to stay on the true side. And I'm going to get rid of it over here on the false side. So next, I need to check either bigger or smaller. So, I don't know. Let's check smaller. Because 0 is small and it's easy to calculate with. So 0 is less than 6. So I'm going to put a 0 in for G. I'm going to put a 0 in there. So I get 7 times 0 is greater than or equal to 42. And we know that anything times 0 is 0. So 0 is greater than or equal to 42 is a false statement. So if I choose a number that's smaller than 6, then it's going to be false. So the smaller than, the less than sign goes on the false side, and that means that the greater than sign goes on the true side. Anything greater than or equal to 6 will make this true, and anything smaller than 6 will make it false. Last one from me, and then you can try these on your own. A number minus 8 has to be equal to 15. That's going to be my balance point. So let's see, that's going to have to be 23, right? So this is going to be true when A is something to 23. That's my balance point. 23 minus 8 is 15. That'll give me 15 on both sides. It's false when A is something to 23. Not sure what the signs are going to be yet, but I'm going to figure that out right now. If I make A equal to 23, so I'm going to substitute a 23 in for A, I'm going to get 23 minus 8 is less than or equal to 15, and 23 minus 8 is 15. So 15 is less than or equal to 15 is a true statement because they are equal. So true gets the equal sign. So the equal sign part of my inequality is going to go there. Now I just check bigger or smaller. Let's check smaller again. Let's go with 8 because that's nice. 8 minus 8 is 0. So I'm going to plug an 8 in for A. So I get 8 minus 8 is less than or equal to 15, and 8 minus 8 is 0, and 0 is less than or equal to 15. So this is a true statement. So if I choose a number smaller than 23, I will get a true statement. So the true gets the less than numbers, and the false gets the greater than. All right, you can check these out, but that's the idea here. We're trying to figure out all of the ways to make a true statement, all of the ways to make a false statement, and the key is to find the balance point. And once you find the balance point, then you just got to test a few things. I hope that helps. I'll see you again next time.